Right, we have this question on the board, okay? We are to evaluate limit of 4x squared plus x minus 1 all over 3x squared minus 2x plus 1 as x tends toward infinity. Once x is tending to infinity, in most cases, if we substitute the value of x, which is infinity, directly, following, you're going to arrive at indeterminate term in most cases. Why not try that out? Put in infinity for x here. If you work it out, you will get infinity over infinity, which is a meaningless term, indeterminate. Hence, we have to do something to this problem. There are two possible things you can do, either of them. You can use the highest degree here, which is x squared. Is that okay? To divide each term in the numerator and in the denominator. You can also use the hospital rule, where you differentiate as many times as the highest degree of this function. And the highest degree, that is the highest power of x, there is 2. So you differentiate 2 times to get the result, alright? Now I'm going to use the dividing procedure first. So we have a limit of that function as x tends to infinity will now be equal to, let us now divide each term by x squared, which is the highest variable degree. So we're going to have 4x squared all over x squared plus x over x squared minus 1 over x squared. Everything all over. To the denominator, you have 3x squared over x squared minus 2x over x squared plus 1 over x squared. Now you will notice that this x squared and this will cancel, and then this one and this x squared will cancel. This x will divide one of the x in the denominator, one will be left in the numerator, and then coming here the same thing, this x will cancel 1 from the denominator, you have 2 over x. Good. Now if you look at this, what we have left is 4 plus 1 over x from here. This is 4 plus 1 over x, then minus 1 over x squared all over. This part gives us 3. This is minus 2 over x, and then plus 1 over x squared. Okay, at this point you can now substitute your infinity. Is that okay? You can substitute infinity. You have 4 plus 1 over infinity minus 1 over square of infinity all over 3 minus 2 over infinity plus 1 over square of infinity. Now, before this time around, we've already in the previous video established the properties of what? 0 and infinity. So we're going to apply that here. Okay, 1 divided by infinity will give us infinity. Any constant number, positive or negative, divided by infinity will give you infinity. And so that's going to be 4 plus 0 minus 0 all over 3 minus 0 plus 0. So you notice, therefore, that the limit of the function 4x squared plus x minus 1 all over 3x squared minus 2x plus 1 as x approaches infinity. The result is, from here, what is left is 4 over 3. Is that not so? So have 4 over 3 as a result. In the next video, I'm going to use the hospital rule to solve this same problem and arrive at this same answer. I'll have this question on the board, okay? We have to evaluate limit of 4x squared plus x minus 1 all over 3x squared minus 2x plus 1. X tends to infinity. Remember, in the previous video, we solved this problem using the division process. So this time around, I'm going to use the hospital rule. So in doing that, that will be equal to, according to the hospital rule, we are going to differentiate with respect to x, the numerator term, alright? And then divided by, we'll differentiate with respect to x, the denominator term, alright? And the point now is, how many times are we going to differentiate? We're going to differentiate 2 times. How do we know that? The highest power of the variable in this function is 2. So we're going to differentiate 2 times. If it is 3, you differentiate 3 times. So our first derivative here, which we have, if I differentiate 4x squared, it's going to give me what? 8x plus, if I differentiate x, I'll get 1. Differentiate this constant, you get 0. Come to the denominator, 3x squared, differentiate, you get 6x, and then come over here, differentiate the minus 2x, you get minus 2. Differentiate this constant, 1, you get 0. So this is what we obtain here. Again, we are going to proceed to still differentiate with respect to x, the numerator again, that is the second derivative, is that okay? Divided by differentiate with respect to x, the denominator, 6x minus 2. So working around that, this is going to give us, if you differentiate your 8x, what will you get? You get 8, differentiate this constant, you get 0, all over, come down to the denominator, 6x, if you differentiate, you get 6. Differentiate minus 2, which is constant, you get 0. If you work out this, it can simplify further. 2 can divide, so you have 4 over 3. Is that okay? And so you are done because there is no variable in this again. So we'll conclude, therefore, limit of 4x squared plus x minus 1 all over 3x squared minus 2x plus 1. As x tends to infinity, the result is what? 4 over 3 by hospital rule. By hospital rule. Remember, I've told you can also pronounce this as hospital. Okay, so that's the solution. Alright, so we'll have this question on the board. We have to evaluate limit of x cubed plus 3x all over 2x squared minus 5 as x tends to what? Infinity. Do you know what? I kind of like this question. You know why? Don't worry. You're going to find out. This question is going to expose one secret for us. Is that okay? But first, we're going to solve this problem using the division process. And then I will solve it using the hospital rule and then expose that secret from that the hospital rule. The reason is that most times we apply the hospital rule unnecessarily, without knowing the limits to which we have to differentiate. You don't just differentiate anyhow when applying the hospital rule. And that is why I like this question. So the question is going to expose it for us. Now, we're going to solve this. So this limit of the function given to us of x cubed plus 3x all over 2x squared minus 5 is equal to, using the division process, the highest variable degree here is x raised to the power what? 3. So we're going to use that x raised to the power 3 to divide each term in the numerator and denominator. So this is x raised to the power 3 divided by x raised to the power 3. Now have 3x over x cubed all over 2x squared over x cubed minus 5 over x cubed. And so we're going to get this x cubed over x cubed is 1. We know that, right? Then plus 3. This x will cancel 1x from denominator. So you have x squared under all over. This will give us 2. This x squared will cancel x squared from denominator. And then x will be left. Then 5 over x cubed. At this point, we are now going to substitute the limit infinity given to us. We'll have 1 plus 3 over square of infinity. Then everything all over to the denominator, 2 over infinity minus 5 over infinity raised to the power 3. And so this is going to give us 1 plus 0. Remember, a constant number divided by infinity is 0. Then all over, this one also 0, minus this also 0. And you know this will give us 1 over 0. 1 over 0 is what? 1 over 0 is infinity. Is that clear? That's the property of zeros and infinity. Take note of that, please. Therefore, the limits x cubed plus 3x all over 2x squared minus 5 as x tends to infinity is equal to what? Infinity. So this is our result. Now stick around. We're going to take a break. When we come back, we'll use the hospital rule to solve this problem and then expose our secrets. You're working from a break. Now we're going to solve this problem this time around using the hospital rule. And then while we are solving using the hospital rule, I don't want to tell you, please, the way we use the hospital rule shouldn't be unnecessary. Sometimes in using the hospital rule, we just keep differentiating and differentiating and differentiating. It doesn't work that way. Quickly, let me remind you something. In our previous class, where we dealt with limit of function where the variable tends to a real number, you notice that in cases where I used the hospital rule, we would differentiate up to a point, maybe like once, before substituting that real number. Is that not so? Then you recall that there was a question we solved, in question number 1, alright? In applying the hospital rule, we differentiated as many times as the degree of the function we're dealing with. In that question, the highest degree of that problem was 2, x raised to the power 2. You remember that, right? Now we differentiated that function 2 times and then got 4 over 3 as our result using the hospital rule. Does it now mean that in all cases you have to differentiate as many times as the degree of the function given to you? The answer is no. That is why you want to be careful and actually know how and up to what limit do you apply the hospital rule. Now let us walk around this and see. This is limit of x cubed plus 3x all over 2x squared minus 5 as x tends to infinity. For this problem, you notice that the degree of numerator and denominator are not the same. Is that not so? So using the hospital rule, differentiate as many times as n minus 1, or simply differentiate n minus 1 times. Alright, now I'm going to tell you what n means, where n is equal to the highest degree in the function. So I'm going to ask you this question, please. Look at this function. What's the highest degree in it? Is it not 3? It means if you are differentiating n minus 1 times, you're going to differentiate how many times? 3 minus 1 times, which is what? 2 times. Does it make sense? And now when you differentiate 2 times, you can now substitute your what? Limit, which is infinity. So that is how you handle such problem in cases where the degree of the denominator and numerator are not the same. So let's work it out. Therefore means that this is equal to, the limit of this function is now equal to, we're going to differentiate this 2 times. Let's go for the numerator. If you differentiate, you're going to have 3x squared here, and then plus differentiate this, that is this, you're going to get 3 all over, differentiate 2x squared, you will get 4x. Differentiate this constant, you get 0, it goes up. This is the first derivative, you know that, right? That's the first derivative of the function. So let me write, this implies f prime, that is first derivative of the function. Then we are going to get f prime prime now, that is second derivative, which means we are going to differentiate this. Let's differentiate this term now and see. Again, if you differentiate, you're going to get 6x for this, and then differentiate this, you get 0 all over. Differentiate this, you get what? 4. This implies second derivative of that function. Now at this point, you can now substitute the limit. So that's going to give us 6 times infinity all over what? 4. And if you do that, you will get infinity over 4. Infinity over 4 is what? If you divide infinity by a constant number, a real number, you will get what? Infinity. Therefore, limit of that function, x cubed plus 3x all over 2x squared minus 5, as x tends to infinity, the result still gave us infinity as what we did before the word break. So the secret exposure is this. How many times do you differentiate when using the hospital rule? It depends on the degree of the numerator and the denominator. If they have equal degree, then differentiate as many times as the degree. But if the degrees are not equal, differentiate n minus 1 times, where the n represents the highest degree in that function. And once you do that, substitute the given limit. Now we have the fourth question on the board. Is also a past question. We have to evaluate root x minus root 2 all over x minus 2 as x tends towards 2. Now looking at this problem, if you substitute that 2 directly into that function, you are going to get an indeterminate term. You can try it out. Alright, fixing 2 for all x here, you're going to get 0 over 0. It means we cannot substitute this 2 directly, so we're going to apply one of the process that can work conveniently. Being that this is an indeterminate term, the hospital rule is best. Alright, you can't go saying you're dividing through by the variable with the highest degree there. It wouldn't work in this case, and you can factorize this. So we are going to differentiate. So this is the same as limit as x tends to 2 of the derivative of this. This root x, once you have this root of something, of a variable you want to differentiate, please use your indices law, change it to what? To fractional index. Root x is the same as x raised to the power half. Then you differentiate that. So I want to obtain the derivative of this. To differentiate this, you use the 1 over 2 to multiply this x. So that's going to give us 1 over 2 times x. Then subtract 1 from that power. If you subtract 1 from half, you're going to get minus half. So minus 1 over 2. Alright? If you differentiate this root 2, you will get 0. It's a constant. So the derivative of a pure constant is 0. Divided by, differentiate this x, you get 1. Differentiate this minus 2, you get 0. Now, that term, if you simplify it further, you're going to get 1 over 2 root x. You know why? that x raised to the power minus half is the same as 1 over x raised to the power half by indices law, negative power. Is that okay? And so anything raised to the power half is the same as square root of that thing, so that's square root of x. Therefore means that this term x raised to the power minus half is the same as 1 over square root of what? X. That square root of x will multiply these two, and you see that here. So at this point we can now substitute our limits. That's going to give us 1 over 2 root 2, because the limit is what? 2. Good, this could be your result, but there's something you should know. In most cases, when we have this root, alright, that is an irrational number, like root of something in the denominator, we usually rationalize. That we learned under sort. So we're going to multiply the numerator and denominator by what we call the conjugate of the denominator. For this, the conjugate is 2 root 2. So we're going to multiply numerator by 2 root 2 and then multiply denominator by 2 root 2. So we're going to multiply this by 2 root 2. Good. Simplifying this further, let's see what we're going to get. This will give us 2 root 2 all over. To multiply this, you're going to do this 2 times 2. That is the number that is not inside the sort, the non-sodic part. 2 times 2 will give us 4. And then you multiply out the sodic part. Root 2 times root 2 will give you 2. Do you know why? Root 2 times root 2 will give you root 4. Because that 2 times 2 inside the sort will give you 4. And then root 4 is what? 2. So this is going to give us 4 times 2. And mathematically, these 2 and 2 will cancel out, alright? And so you have root 2 over 4 as the limit of that function. So limit of root x minus root 2 all over x minus 2 as x tends to 2. Your result is root 2 over what? 4 as your answer.